Hi everyone. The focus of this week's module is ventilation. First, we'll talk about why you need to ventilate, indoor air quality, code requirements, and touch on the connection between ventilation and energy efficiency. Next, we'll go into more detail about the specific ventilation equipment. For the kitchen, it's a hood, and for the bathroom, it's an exhaust fan. And finally, finish up by doing some practice calculations. We'll talk about how you measure ventilation and then how you size the ventilation equipment. So let's start out with the broad picture. Why do we need to ventilate our kitchens and bathrooms? First of all, we need to keep our occupants safe by reducing indoor air pollution. Turns out that 90% of our lives are spent indoors in our modern lifestyle, and there is 2 to 5%. It's not percent. There is 2 to 5 times more pollution indoors than outdoors. So we're going to reduce the indoor air pollution, keep our occupants safe. We also need to reduce moisture. And this is important specifically in kitchens and bathrooms, which are great producers of moisture. We've got boiling pots and dishwashers in the kitchen. We've got showers and steam saunas and toilets in the bathroom. All right, all of which are bad for the building environment and also can foster mold, which is bad for the indoor air quality. All right. Finally, we must ventilate because it is code required for those same reasons, that it's going to keep our occupants safe. So, what is this indoor air pollution that we're talking about? What is in our indoor air? Here are 4 categories of indoor air pollutants. The first one is airborne particles. Uh, this is the only one, by the way, that filtration or air cleaning or purifying systems help with. Can include diesel exhaust, dust, hair, including pet hair and dander, and pollen. Household odors and gases are a second major cause of pollution, including cooking odors, pet smells, cigarette smokes, etc. The next one is one that you as a designer can have a large impact on, and that's VOCs or volatile organic compounds. These come from paints, glues, varnishes, wood preservatives, and you can specify low VOC products. Finally, microorganisms such as bacteria and mold. Again, we can drastically affect the amount of mold in our homes by removing the moisture. All right, and so the ventilation system helps with that. There's 3 basic or major strategies to improve your indoor air quality, and they are source control, improved ventilation, and air cleaners. Source control is going to be your most energy efficient and low cost approach. Basically, you're going to eliminate some sources of pollution or reduce their emissions. All right, and then you don't have to take those pollutants out of the air because they're not even there. All right. Source control for kitchen and bath products projects specifically include reducing moisture, reduce or eliminate the use of gas-powered cooking devices. All right, and specifying low VOC and no formaldehyde products. The second basic strategy to improve your indoor air quality is improved ventilation, and basically we increase the amount of outdoor air coming indoor. So for kitchen and bath projects, you'll want to first design for natural ventilation. We talked about that a little bit in our lecture on cooling. Next, you want to provide mechanical ventilation, and that will include hoods over every cooking device and also bathroom exhaust fans. The third strategy to improve indoor air quality is to use air cleaners. They are specifically for particle removal and not for any of the gaseous pollutants. You can use them for kitchen and bath projects. Less common. All right. They could be portable air cleaners or purifiers for a single room or area, or you can have filters designed into your central AC system. Another reason we need to ventilate our projects is because it's code required. So California requires two types of ventilation in residential projects. One is a whole house ventilation, and the other is local exhaust ventilation. So in the whole house category, you need to know that mechanical ventilation is now required for all homes in California. Didn't used to be, but now it is. Okay, so new construction, alterations and additions over 1,000 square feet all trigger this requirement. Although when you go through all the calculations of the required size for this ventilation requirement for these smaller homes, a bath exhaust fan, for example, might be enough for the entire house. All right, so this isn't a big deal. The other one for local exhaust has specific requirements for kitchen and bathroom. For kitchens, mechanical ventilation is required in all kitchens. It can be either intermittent, you turn it on with a switch, or continuous. All right, and there are minimum code requirements for each of those. For the bathroom, again, mechanical ventilation is required in all bathroom compartments. All right, so if you have separate compartments in your bathrooms closed with walls and doors in between, each of those compartments is required to have mechanical ventilation. All right, just an operable window isn't enough. You can either provide the mechanical ventilation with intermittent operation, that's more common, all right, or continuous operation, and they have a code required minimum amount. Let's touch on the connection between ventilation and energy efficiency. In the 1970s, there was a big push to seal up our leaky, drafty buildings that were leaking heat out of all of the doors and windows and the cracks. All right. So you got decreased energy costs, which was great, decreased air leakage, but vastly increased moisture problems, indoor pollutants. You had problems with health, mold, rot, and lots of occupant complaints. All right, in the 30, 40, 50 years since then, we have learned that you need to balance your energy efficiency with your indoor air quality. We still like to build our buildings tightly enclosed buildings with decreased energy use, but you need to also include a well-designed ventilation system. All right. And therefore, you can achieve acceptable indoor air quality, lower health risks, reduced moisture levels, and finally, reduced occupant complaints. That was an overview of ventilation, why we need it in residential projects, and specifically for kitchen and bath projects. Thanks, everyone.